Welcome to Engage Math Lesson 15, problem number 2, where we are working with exponent rules. What I did was I looked at the back of the Algebra 1 Engage Math workbook and picked the exponent rules that will actually apply in this problem and wrote them at the top so that they're really handy. But you can always look at the back of your workbook at the reference sheet inside back cover and you will see all of these rules. Okay, let's get started. The first rule is that if we are dividing and there are exponents involved, and the base, meaning the a and the a are the bases, are the same, we can just simply subtract those exponents. The reason that that's true is that we really have d multiplied by itself 12 times. I could keep going, over d multiplied by itself 3 times. And when you think about that, what you're really doing is canceling 3 over 3 because the 3 d's in the numerator and 3 d's in the denominator are simply 1. That's why you can just subtract the exponents, because you'd be left with d to the 9th in the numerator. So let's kind of look at this for a minute and look at that rule and see how that's going to help us right here. D to the 12th over d to the 3rd is simply 12 minus 3 for the exponent. So our final answer for this one is simply d to the 9th. Now we're going to do the same thing in B, except I don't want you to forget what you've known for years. 6 over 2, we're not going to subtract 6 over 2 like we did with the exponents in the previous problem. 6 over 2 is exactly what it's been since you first learned to reduce fractions. 6 over 2 means 6 divided by 2, or 3. So we're going to take care of the 6 and the 2 the way we always have. Those are not exponents. They're just coefficients on the variables. K to the 22nd over k to the 8th. We subtract 22 minus 8 and we get k to the 14th. And then one of our other really important rules in this section is that anything to the 0 power other than 0, we can't have a being 0, but any other value that is raised to the 0 power is going to be 1. So in this case, j to the 0 power is simply going to be 1. We could write times 1, but why bother? Our final answer is simply 3k to the 14th times 1, which is 3k to the 14th. Now, the other thing I just want to make sure you understand is why something to the 0 power equals 1. Let's just take a little aside example here. I don't know, let's pick something like, how about x to the 7th over x to the 7th? Now, we know from the rules we've been covering today that that is going to be 7 minus 7, or x to the 0. The reason that that's also equal to 1, which is more simplified, is because anything divided by itself is just 1. So we already knew that x to the 7th over x to the 7th was 1, but this shows why if we end up with something to the 0 power, we already know the value of it is 1. Okay, hope that clarifies that just a little bit. Okay, let's go to the next one. And once again, in problem C, letter C, what we're going to do here is we're going to once again reduce that negative 6 over 8. And we know that that reduces from the old days where you first learned how to reduce fractions to negative 3 over 4. That takes care of that. 12 minus 7, the exponents on the x, will give us x to the 5th. And then y to the 5th over just y. Remember, there's an exponent of 1 there, even though it's not written, will give us 5 minus 1, or an exponent of 4. We're done. This is our final answer. Okay, now let's look at the next one. And oh, wait a second. We could do this problem in about 1/10 of a second. Why? The reason is because anything to the 0 power is 1. We're done. That whole quantity is to the 0 power. We know it's equal to 1. Okay, let's go to E, and we're going to quickly subtract each of these exponents. 3 minus 3 is 0. I'm not even going to write it because I know x to the 0 is just 1. Why bother? Why bother writing x to the 0? We know it's 1. Okay, so now it's y to the 8th over y to the 5th, which is y to the 3rd. And then 20 minus 3 gives us z to the 17th, and we are done. Okay, let's look at the light bulb problem. So this problem uses this last formula on the left. We can raise each one of the factors in the parentheses to the 2nd power. So really what we have here is 3 to the 2nd, w to the 2nd. Because remember, there's really an exponent of 1 on the 3 and the w, so the 2 multiplies each of those exponents. That's why we're getting 3 to the second, w to the second. And then we have yz to the fifth, or sorry, wz to the fifth. Okay, now there's one other formula that I thought maybe we did it in a previous lesson, but I might write it out here again. It was kind of in the previous problem on this lesson. And that is that if we have a to the m times a to the n, we're going to add those exponents and get a to the m plus n. That's going to come in handy with this light bulb problem because now we have w squared times w. So we're going to have to combine those in a minute. And it's all over 18w squared. Okay, 3 squared is 9, but 9 over 18, I'm kind of doing 2 steps at once here, is 1 over 2. You don't have to write the 1 in the numerator, but it doesn't hurt to do that if you want. That's 9 over 18. W squared times w. These two are going to give us w to the third, and then we have w squared in the denominator. Again, I'm going to do 2 steps at once. The w to the third over the w squared is just going to leave us with w to the first in the numerator. So let me just kind of take that and, well, let's do it as 2 steps actually. Okay, so now what we have is z to the fifth in the numerator. All right, one last step. We really, as our final answer here, are just going to have w to the first, z to the fifth in the numerator, over 2. And sorry, the z's, I'm kind of putting that little line there to make sure you know it's a z. But that's our final answer. So with the 2 in the denominator, the w to the third over the w squared just leaves us with w to the first. And we're done. Our final answer is wz to the fifth over 2. Done. Great job. Thanks for joining us here today at Engage Math.